In how many ways can the sum of three distinct six-sided dice be n, right? So in other words, let's say you have three dice and they are distinct, so we're gonna differentiate them. So maybe you have a red, a blue, and a green die. And so let's say the first one is the red, this is the blue, and this is the green one. And you want to know in how many ways you're able to get a certain sum n. Now, of course, n can only be from 3 to 18 because each one of the dice is a number between 1 and 6. So the maximum is going to be 18, the minimum is going to be 3. So for example, there's only one way to obtain 3 if the three of them are 1, right? But how many ways can we get 12? How many ways can we get the number 15? And so on, right? So again, we're gonna solve this using generating functions. So how do we, let's start by encoding each dice. So we encode each dice as, so each dice, you can't have the value 0, so that's why you start with x to the power of 1. So x squared plus x cubed plus x to the power of 4 plus x5 plus x6. And so each dice, you're going to encode it with something like this. And then the generating function we're interested in is just multiplying all of these. So it's just this sum again of these powers starting at 1. And here you multiply 3 times, so this is to the power of 3. And you can factor out a x cubed term, and it'll give you something like this, plus x squared plus x cubed plus x to the 4 plus x to the 5 cubed. And we are interested, what is an? So what is this equal to? Right, what is an? Okay, so the first thing is we can simplify, so we can try to find like a more closed formula for this. Let me copy this and go to a place with more space. So let's copy this here. And so we can simplify this. So if we take 1 plus x squared plus x cubed plus x4 plus x5, this is just a finite geometric progression, and you can write it like this. So, and we have a video where we talked about before about the finite geometric progression. So it's always good to know these techniques. Okay, and then a of x is gonna be just x cubed times that, right? Times this 1 minus x to the 6 over 1 minus x, all of this to the power of 3. And if we open this up and do all the algebra, let me write it here. It'll just be an x cubed times, and you'll get 1 minus 3 x to the power of 6 plus 3 x to the power of 12 minus x to the power of 18 divided by 1 minus x cubed. So you get something like this. And now what we need to do is we need to be able to extract the coefficients from something like this. Remember, at the end of the day, all of this is going to be equal to some a0 plus a1x plus a2x squared and so on. And we want to know what is an. So we want to know what is an here. So we need to extract the coefficient of x to the n in this here. Okay, so let me copy paste this here. make our life easier. So we want to extract the coefficient of this, the nth coefficient of this polynomial here, of this series here. And what we're going to use first is this bottom part. So how do we deal with this 1 over 1 minus x cubed? Well, we saw in a previous video we saw this negative power identity. So we saw that 1 minus x to the power of minus m was equal to equal to 0 to infinity n plus m minus 1, choose n, x to the n. So we saw that this was the case, but again, this followed from, so if you go back to the video on the generalized binomial theorem, we showed how with the general binomial theorem, if you replace by a negative here, you end up with this expression here. So if we now replace this, like if we just make m equal to 3, so for m equal to 3, and I can just replace it here. So if m is equal to 3, so to the minus 3 here, so this will be, so n plus m minus 1, so this m here will be a 3 minus 1, x to the n, and so this is just going to be the summation of n equals 0 to infinity of n plus 2, choose 2, x to the n. Okay, and now if we multiply this by 3, so we're going to have a bunch of these terms, right? So we're going to have, if you think about it, we're going to have an x to the cube 1 minus x cubed. We're going to have minus 3x to the 9, 1 minus x cubed, plus 3x, so to the 15, 1 minus x cubed, minus, and then to the 21, x to the 21 over 1 minus x cubed. And so we need to be able to compute all of these, right? All of these. So this one here, if you multiply by x cubed, 1 minus x to the minus 3, what you'll get is the summation here for n equal to 0 to infinity of of n plus 2, choose 2. But now when you multiply by x cubed, you add 3 here to this n, x n plus 3, and we saw that we can do the shifting indices thing. So when you have an n plus 3 here, this whole thing, you can rewrite it and as a shift index. So here, this is going to be the summation. So this here shifts everything. So if this one is going up by 3, you just need to go down by 3 on this part here on the left. And so this will be starting at 3. And if you do n plus 2 minus 3, you get n minus 1, choose 2, x to the n. So that takes part of this first one. Now for these ones, you do the same thing. You just need to shift these indexes. And so I'm going to show you what that looks like. So these are just going to be each one of those terms here that we need to find, right? So the first one you shift by 3. So here we wrote it as k just to end with n here, but essentially this here you can write it in this way, and when you shift by 3 here you can subtract 3 here and you end up with this. Now when you do x to the 9 here, same, you get this formula here, so you shift by 9 here and so you subtract 9 here, so plus 2 becomes a minus 7, and same for all of these. And so these give you the expressions that you need to replace for each one of these without still the constants. And so when you do that, what you'll get, so if you do the replacement for all of these with the constants, what you'll get is that the term you're interested in, your an, is going to be this n minus 1 choose 2, and the coefficient that was appearing was a 1 in front of that. So n minus 1 choose 2 with a 1 in front. Then here, a minus 3, now for this one here, but this one here, the x to the 9 one, has the coefficient n minus 7 choose 2. So you get minus 3 n minus 7 choose 2. Then the next one is from the x to the 15. So the x to the 15, we had a plus 3 here, so it's going to be 3 times n minus 13 choose 2. So you see 3 times n minus 13 choose 2. And finally, from the x to the 21, it was just a minus in front. So it's going to be minus n minus 19 choose 2, which is exactly what you get here. So this gives you the formula for how many ways can you get the sum of 3 six-sided dice equal to 15. You just replace n by 15 here, and you just compute all of these, and it'll give you the value. Now, notice that, remember that when you do a choose, like if you do m choose 2, and if m is smaller than 2, this is 0. Notice that the sum can be at most 18, so this term here, the 18 minus 19 is going to be minus 1. So this term here is always going to be 0, which means that you can always ignore this term. And so the actual formula is just the sum of these three terms here.